This video will focus on the learning target. I can use the kinetic molecular theory to explain the movement of gases. So what's really cool about gases and why we study them in their own separate unit is unlike liquids and solids, gas properties are really determined by the fact that they're gases and not so much by the fact that they're a specific element or molecule or compound. Okay, so gases as a state of matter are that state of matter that are super spread out, right? They fill their whole container, they're compressible, they're high energy. And because of that, the things that dictate gas behavior, again, is not the element or compound, it's really properties of gases. So the pressure the gas is experiencing, the temperature the gas is under, the amount of gas that's present, the volume the gas takes up, and something called the kinetic molecular theory. And the kinetic molecular theory is the explanation for how things are moving, kinetic, because they are molecules. So as we go into this today, realize that every single gas molecule exhibits these behaviors regardless of what elements are within the structure. So whether it's water that's a gas, or oxygen that's a gas, or nitrogen that's a gas, they all do the same thing in relation to kinetic molecular theory, and they all are affected similarly to pressure, temperature, amount of particles, and volume. So again, the kinetic molecular theory is the idea that since all particles are in motion, kinetic is motion, they behave a certain way. Because particles are moving, number one part of the kinetic molecular theory is that their motion will be in straight lines. Okay, there's no reason, because of how particles work, that they would be moving in a parabola or that they would be moving in zigzags. All particles move in constant straight lines, so constant linear motion. The second piece of the kinetic molecular theory then is that because they're moving in constant straight lines, the only way that they're going to change directions is they hit something. So if particles hit walls or each other, that's when they'll change directions. And then the third part of the kinetic molecular theory is that when we're talking about gas behavior, the assumption is that gases are acting in an ideal fashion. And I'll talk about what an ideal fashion means. So why is kinetic molecular theory cool? When you look at it, you're like, well, it's not that hard. They move straight, they hit things, they act ideal. The reason why we care about kinetic molecular theory is that in the end, it's going to become the explanation for why a lot of things happen. So it explains why, when I open a perfume bottle, someone far away from me might eventually smell it. It explains why, when you put something into water, eventually it dissolves, even if you don't stir it. So the kinetic molecular theory actually explains a lot of the things we see. So if you want to see what kinetic molecular theory looks like, that's what's on the screen here. So one of my favorite simulations, you'll see this multiple times. But what you can see in this display is particles. So these are all supposed to represent particles of gases. And they are moving in straight lines until they hit something, right? And they have lots of space, so they're acting like gases. But essentially, you can see what it looks like to be a gas. The next video will explain what ideal means. Make sure you watch that one too. And then go take the quiz and have a nice night.